Since 2018, every year astronomers have spotted a mysterious blue flash in the sky. This is one of the brightest phenomena in the universe, an explosion that makes an ordinary supernova look like a faint candle in the distance. Some of these explosions have been detected close to us, while others occurred billions of light years away. They look quite similar to each other, but no one knows exactly what they are or what causes them. Through careful observation and analysis, astronomers began to decode some patterns and formulate an initial, plausible theory. But then, in 2023, they witnessed something that left everyone completely baffled. These explosions are called luminous fast blue optical transients, and there is truly nothing else like them out there. Hello everyone. Thank you for joining me today. Let's dive into the mystery of space's brightest explosions, uncover how they were discovered, and explore why they keep stumping scientists again and again. Have you ever heard of LFBOTs? Being such a recently discovered event, the data we have on luminous fast blue optical transients, or LFBOTs for short, is still very minimal. The first LFBOT ever detected was identified just 6 years ago, in 2018. And since then, scientists have only witnessed a handful of them. Because our knowledge is still so limited, coming up with a universal definition is quite tricky. For now, what scientists do agree on are a few common characteristics that these LFBOTs seem to share. So far, they all display a predominantly blue emission, extremely high optical luminosity, and are remarkably bright in X-rays, ultraviolet rays, and radio waves. Not only that, LFBOTs are also incredibly fast, just as their name suggests. They go off like a cosmic camera flash, reaching peak brightness and then dimming rapidly, usually within just a few hours or days. Did you know that a supernova follows a similar pattern of brightening and then fading? But this fading process takes weeks or even months. Because of this fleeting nature, LFBOTs are very difficult to spot and study. So, how did scientists manage to capture such an elusive event? In Hawaii, NASA's ATLASHKO telescope is part of an early asteroid impact warning system. This system scans the entire sky several times a night, searching for moving objects. On June 16, 2018, while performing its routine scan, Atlas HKO recorded something truly extraordinary. A flash, 100 times brighter than a regular supernova, which disappeared within days. Immediately, a scientific scramble began. Scientists quickly analyzed the data to understand what they had just witnessed. They pinpointed the explosion as coming from the Hercules constellation, about 180 million light-years away. The event was officially designated AT 2018 COW, and affectionately nicknamed the Cow, after the last 3 letters in its name. Once its location was established, it was quickly classified as a type IB supernova. This kind of supernova, also known as a core collapse explosion, occurs when massive stars collapse under their own gravity. But something about this explosion just didn't quite fit. Upon closer examination of the COW's emission spectrum, scientists realized it didn't look typical for a type IB supernova. Its emission lines were unusually broad, and the helium lines were very weak. They thought it looked more like a type ICBL supernova, so it was quickly reclassified. However, the more scientists pored over the data, the more surprised they became by what they found. Whatever this explosion was, it started to look less and less like any kind of supernova we know. At least, not the kind of supernova we'd expect. For starters, it appeared out of nowhere, seemingly from nothing. This blast went from completely inactive to peak luminosity in just a few days. As we mentioned earlier, Supernovae usually take a few months to reach their brightest, and then fade away just as slowly. Not only that, this event was recorded to be 10 to 100 times brighter than an ordinary supernova, and everything about the way it exploded was wrong. When supernovae explode, the energy is typically released in a spherical shape. We now know that shock waves sent out after a supernova can be aspherical due to strong magnetic fields, but that still doesn't explain the strange nature of this explosion. If you enjoyed this video, please give it a like and subscribe to the channel for more fascinating content. However, upon closer inspection, scientists found that this mysterious explosion didn't even explode spherically. The researchers themselves called it the most aspherical explosion ever observed. Soon enough, other theories started to surface. Some suggested the cow could be a monster black hole shredding a passing star. Others thought it might have been a supernova that gave birth to a black hole or a neutron star. But let's pause for a moment. Do you think any firm conclusions can be drawn when there's only one single case? As the saying goes, once is an anomaly, twice is a coincidence, and 3 times is a pattern. What researchers really needed was a bigger sample size, more instances of this kind of explosion. So, they could compare observations and look for any patterns that might arise. Luckily, it didn't take long for scientists to set their eyes on a second similar explosion. Just a few months later, in September 2018, the cosmic camera flashed again. And then, for a third time in 2020. Following the tradition of giving animal nicknames based on the last 3 letters of their official names, we now had the beginnings of an LFBOT zodiac, with the cow joined by the koala and the camel. And just like that, they had data on 3 separate LFBOT events, enough to start hunting for patterns. When analyzing the cow, koala, and camel, the first thing that stood out to researchers was the location of these events. Even though they all happened in different parts of the universe, each explosion was recorded as coming from inside the spiral arm of a galaxy. At first, this information strengthened the initial theory that LFBOTs were just a type of core collapse supernova. The kind of star that causes a core collapse supernova is a massive star, one of the biggest types of stars in existence. And as you may know, the bigger the star, the shorter its lifespan. This means these massive stars don't get the chance to travel very far before they reach the end of their lives. So, it makes sense that their supernovae would occur very close to the star cluster where they were born. And which part of the galaxy is famous for having such star clusters? That's right, the spiral arms. The very place where all 3 LFBOTs were observed. But just as researchers felt they were making real progress, something happened that completely caught them off guard again. Like the Atlas HKO in Hawaii, the Zwicky Transient Facility is a very wide-angle, ground-based camera that scans the entire northern night sky every 2 days. In 2022, it detected another similar explosion. But after the initial blinding flash, this optical transient started to behave quite strangely. Instead of exploding once and fading away within a few days like previous LFBOTs, the so-called Tasmanian devil continued to produce short-duration bursts for much longer than expected. What's more, each of these bursts appeared to be just as bright as the original explosion, which was very strange indeed. The Tasmanian devil emitted more energy than hundreds of billions of stars like our sun combined. Once again, researchers were left deeply puzzled. This was something they had never seen before in the field of astronomy. Now, I'm sure some of you skeptics are probably thinking, this must just be some kind of technical error. Maybe the equipment was miscalibrated, there was a glitch during testing, or it was simply a mathematical mistake. In reality, The history of science is full of moments where scientists celebrated great discoveries, only to be let down once someone double-checked the results. But this time, that's not the case. The data was confirmed by 14 other telescopes around the world. All of them verified that the Tasmanian devil really did produce at least 14 bursts of light, and the actual number could be much higher. Even more surprising, these massive energy pulses happened just minutes apart. Scientists describe this phenomenon as if a star kept dying and then coming back to life over and over again. If that's truly the case, this strange phenomenon could offer completely new insights into the life cycles of stars. Up until now, stellar life cycles have only been studied as snapshots of different stages, never as a continuous process. In short, even though the multiple bursts of light from the Tasmanian devil were completely unexpected, there was still reason to suspect that these explosions could have been a strange type of supernova, since none of the observations directly contradicted the core collapse supernova theory. But what happened next changed everything. If it were you, do you think science is ready to embrace such paradigm-shifting discoveries? On April 10, 2023, astronomers detected yet another big blue explosion, with all the same characteristics as its LFBOT zodiac relatives. But this time, it wasn't anywhere close to where it was supposed to be. Unlike every previous LFBOT, which were always found in the spiral arms of distant galaxies, the Finch wasn't in a galaxy at all. Located 3 billion light-years from us and 15,000 light-years from the nearest galaxy, it stood alone in space. It was right in the middle of nowhere, exploding in the void between two galaxies. This discovery was a major blow to the leading theory. If these explosions really were the result of massive stars undergoing core collapse, there's simply no way they would be happening out in the space between galaxies. So, it was back to the drawing board for researchers, starting over from scratch. Don't forget to hit the subscribe button and turn on the notification bell so you never miss an update. They came up with 2 new theories to explain what could have caused the Finch to explode where it did. The first suggests that the Finch could be the result of a star being torn apart by an intermediate mass black hole. A black hole with a mass between 110,000 times greater than our Sun. However, the existence of these intermediate mass black holes has never been proven. Their smaller and larger relatives, stellar remnants and supermassive black holes, have both been confirmed to exist. But this middle child remains purely theoretical. Still, if they do exist, could they be responsible for this mysterious light show? Astronomers have shown through simulations that stars can orbit intermediate mass black holes as many as 5 times before being ejected. With each orbit, the star gets torn apart a little more, losing more and more of its mass. Finally, the remaining stellar matter would be flung back out into the galaxy at speeds as high as 10% the speed of light. This would be consistent with the incredible speed and brightness observed in LFBOTs, lending more weight to this theory. One of the most likely places researchers would expect to find intermediate mass black holes is in globular star clusters located in the outer halo of a galaxy. Galaxies have halos that stretch far beyond the main disk and bulge. These halos are especially visible in spiral galaxies like our own Milky Way. In our galaxy, the outer halo extends an impressive 1 million light-years from the galactic center. Some scientists believe it's possible that the Finch may have been located within such a globular star cluster. If that's the case, and intermediate mass black holes really do exist there, it's plausible that the Finch was caused by these unusually sized black holes tearing apart large stars. The The second theory researchers proposed suggested that the Finch could have been the result of two neutron stars spiraling closer and closer together until they collided. This kind of event causes a kilonova, which is known to be one of the biggest stellar explosions in the universe. A telltale sign of a kilonova is the presence of gravitational waves, which come through as a distinct chirp, caused by a rapid increase in frequency as two massive objects spiral around each other, eventually colliding and merging. If scientists could find evidence of this in the data from the Finch, it would strongly support the neutron stars theory. However, as bad luck would have it, our chirp detector, the Laser Interferometer Gravitational Wave Observatory, LIGO, was down for maintenance at the time the Finch occurred. That means we don't know if gravitational waves were actually emitted, since we have no data on them at all. One thing we do know is that no gamma-ray burst was detected, which you would typically expect to see with a kilonova of this size. But remember, this explosion happened 3 billion light-years away. That's an incredibly far distance, possibly too far for any gamma-ray data to reach us. All in all, none of this data can conclusively confirm or reject the neutron star theory. It's definitely frustrating to witness such an incredibly rare, new, and powerful phenomenon and not have the data to fully understand what's causing it. I guess patience really is an underrated virtue for astronomers. But they're not just sitting idly by. Scientists are already planning to use the powerful optics of the James Webb Space Telescope to search for any faint globular clusters at the same location as the Finch. Hopefully, this will help clarify whether they're on the right track with the intermediate mass black hole theory. In the meantime, other researchers are focusing on broadening the sample size. The more LFBOTs we can detect, the more we will learn about them. The 6 LFBOTs we have seen so far have taught us some things, but there's still so much left to learn. The only way we're going to get a larger sample is to keep sweeping the sky with wide-field surveys like Atlas HKO and the Zwicky Transient Facility. Right now, scientists' hopes are pinned on the Vera C. Rubin Observatory, a new telescope currently under construction in Chile. It will scan the entire southern night sky every few nights, and I've actually done a video about it here. The Vera C. Rubin Observatory is expected to be operational by 2025 and will be able to capture 10 times more light than all previous facilities. Follow-up observations with the Hubble Space Telescope and other ground-based telescopes will help analyze even more information, potentially leading to new breakthroughs. LFBOTs are still a super new phenomenon that we don't fully understand yet. Even scientists admit that the discovery of the Finch raises more questions than answers. The more we learn about these bright blue explosions, the more they keep surprising us. All that's left to do is what hundreds of generations of astronomers have done for centuries before us. Point our telescopes up to the night sky, watch, and wait. Do you think you have the patience to keep waiting for the universe's next secrets to unfold? Thank you so much for spending your time exploring with me. If you found this video interesting, don't forget to hit like, subscribe, and turn on the notification bell so you won't miss out on our next adventures. Please share your thoughts, questions, or predictions about these mysterious phenomena in the comments below. I'd love to hear from you. Once again, thank you, and see you in the next video.